Hi everybody, we're finally in Unit 2 in which we solved some quadratic equations today, reviewed some good ninth grade stuff, and sang the quadratic formula, which we'll get to shortly. But to begin, we need to write each of these expressions in simplest radical form. So I have all these square roots here, and I need to know what are my perfect squares that I can tear it apart with. So if you don't know your perfect squares, you better be writing out 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, and keep going on. So I have the square root of 125. And I need to know what are the factors of 125 that one of them is a perfect square. So I need the biggest one. I'm thinking it's 25. Isn't it 25 times 5? Well, what's the square root of 25? 5 square roots of 5. These two numbers are equivalent. They look different, but they're really the same exact irrational number. I have negative 4 plus the square root of 24 all over 2. Well, let's deal with the square root of 24. Let's come over here. Let's tear apart the 24. I know it's so tempting to divide 24 by 2, but you are not allowed to do that because we need to take that square root first. So 24, what are my perfect squares? 1, 4, 9, 16. I'm thinking 4. 4 times 6, good. So 2 square roots of 6 really is what goes into that circle. So negative 4 plus 2 square roots of 6 all over 2. Now instead of writing all over 2, what we can do now is we can distribute that division and get negative 2 plus the square root of 6. That's equivalent to this monster of a fraction up here. Got the square root of 128. So I need to know what's the biggest perfect square that goes into 128. And if you don't know what to do, use your calculators. Divide by perfect squares. Divide by perfect squares is the shortcut. And if you think about it, isn't this 64 times 2? The square root of 64 is 2. Sorry, the square root of 64 is 8 times the square root of 2. So this is really the 8 square roots of 2 over 4. 8 over 4 is really 2 square roots of 2. So hopefully you remembered how to simplify radicals because that's going to come up while we work with the quadratic formula. Find the real solutions to each of these equations. So we talked about that quadratic equations have real solutions that we see when the parabola crosses the x-axis. So the thing is, this quadratic equation is not set equal to 0. So let's try to set it equal to 0. I like positive x squared, so I'm going to make this manipulation here. And now we really should be asking ourselves, what multiplies to negative 40 that adds to positive 12? 1 and 40, 2 and 20, 3 and no, 4 and 10, 5 and 8. None of those make 12. So we reach into our back pocket and pull out the quadratic formula. And hopefully you recall that the quadratic formula tells us that I can solve an equation like this that's set equal to 0 by plugging in the solutions to x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. I know you just saying it right there. So we need to pick off the coefficients of a, b, and c. So what's my a? A is 1 x squared, b is 12, and c is negative 40. I need to take those values and substitute them into the quadratic formula. And that spits out my answers. So my solutions are x equals negative b. What's the opposite of b? It's negative 12 plus or minus the square root of b squared. You're smarter than your calculator. You can square a number in your head. Minus 4 times a times c all over 2 times 1, which is 2. And then you reach over for your calculator and you type in what I call the discriminant. You type in what's under the radical here. You type that into your calculator. So I get, typing in the discriminant there, x equals negative 12 plus or minus the square root of 304 all over 2. So I'm going to end up with irrational answers here because I have that 304 is not a perfect square. And now I need to figure out how do I simplify this radical. I have no idea what multiplies to 304. So I'm thinking of my list. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, and it goes on and on. No, 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 no. Let's try 81. So on my calculator, I'm doing 304 divided by 81 and got some crazy decimal. Divided by 64, I got 4.75. Nope. Divided by 49, no way. 36, nope. 8.444. 25, nope. 16, yes. It is 16 times 19, which leaves me with 4 square roots of 19. So my solutions are x equals negative 12 divided by 2 plus or minus 4 square roots of 19 over 2. So my final answers to that quadratic equation are x equals negative 6 plus or minus 2 square roots of 19. Those are my solutions. They're crazy irrational numbers. You could type that into a calculator and get 2 crazy decimals, but those are my solutions. Let's try this next one here. Notice it's already set equal to 0. I'm not even going to try factoring that because that's just going to be some crazy AC factoring. And this is the quadratic formula lesson, so chances are I want you to use the quadratic formula. So give me an A, 5. Give me a B, negative 10. Give me a C, 17. So we plug those in. X equals the opposite of B plus or minus the square root of b squared. Don't use your calculator here because you're going to type it in wrong. Negative 10 times negative 10 is 100. B squared minus 4 times A times C all over 2 times 5, which is 10. I come over to my handy dandy calculator and I type in the discriminant. If you want to sound fancy, you say the word discriminant. So 100 minus 4 times 5 times 17. And I get x equals 10 plus or minus the square root of negative 240 all over 10. And we ask ourselves, what is going on here? The square root of a negative number? What number times itself is negative? Not any numbers I can currently think of, so we simply state there are no real solutions. If we were to graph this parabola is never going to touch the x-axis because the x-axis is where we see our zeros, and this one doesn't appear to have ones that we can see. So there are no real solutions to this quadratic equation. And finally, this last one doesn't look fun at first, but wait a second, we've got to apply the distributive property. X squared minus x minus 4 equals 2x minus 2. Nice. Let me set it equal to 0, bring everyone over to that x squared term. I get x squared minus 3x minus 2 equals 0. And this looks like a nice friendly equation that maybe we can factor. What multiplies to negative 2 that adds to negative 3? 2 and 1, I need opposite signs. There's no way that's possible. So we pull out the handy dandy quadratic formula. Give me an A, 1. Give me a B, negative 3. Give me a C, negative 2. And we plug it in. X equals the opposite of B plus or minus the square root of b squared. Negative 3 times negative 3 is 9. Minus 4 times A times C all over 2 times A, which is 2. And then I come over to my handy dandy calculator and type in the discriminant and get 17. So my solutions, I'll stop now, are x equals 3 plus or minus the square root of 17 all over 2. Well, luckily 17 is a prime number, so I don't need to worry about simplifying it, but if you see your answers written, you'll probably see them as x equals 3 over 2 plus or minus the square root of 17 over 2, because normally we like to split them up based on the rational part and the irrational part. And those are my solutions. Remember, there's 2 of them. There's 2 numbers here. There's 3/2 plus square root of 17 over 2, and 3/2 minus the square root of 17 over 2. Those are my two different solutions, but we get lazy and just put the plus or minus. So hopefully this was a good quadratic formula review. Hopefully you can now sing the quadratic formula because you need to know it. I know it's on the reference sheet, but I don't care because you're not going to get that. Oh, everybody go, ooh. See you in the next video.